Dear students, welcome back. So, in last lecture we have covered till strain hardening. So now let's start from strain hardening. So what is strain hardening? As you might have studied in strength of material, what is this strain hardening? So as you elongate or as you work on any workpiece, if you do the forming, then as you do the forming, it will get harden and harden. So that is known as strain hardening. So when a metal is formed in cold state, there is no recrystallization of grains, and thus recovery from grains distortion or fragmentation does not takes place. So as you do the forming, it will get harder. If you continue doing forming, it will get more harder, and that may result in fracture. So you might have seen like a hammer is there. Sorry, not a hammer. Some other iron piece is there. If you start hammering it, then first it will reduce in size cross section. But after some time, if you continue hammering, then it will start fracturing. So that indicates that there is a limit of going for cold work. You cannot go more cold working. Then what is the solution? For that particular case, if you want more cold working, then you have to heat that. There is no other option. So cold working is always followed by annealing process, that is heating, to get the further cold working, or to get the further deformation. Otherwise deformation is not possible without fracture. So as grain deformation proceeds, greater resistance to this action results in increased hardness and strength, and that's known as strain hardening. So you must remember this point. So strain hardening is the action by which material will resist to the deformation. So it is given by sigma equal to k epsilon power n, where n is the strain hardening exponent and k is a strain hardening constant. So this formula is very important from strength of material point of view as well as production point of view. You must remember this formula. So sigma equal to k epsilon power n. So that's for cold working, and for hot working it is given as sigma equal to some constant c into epsilon power m. So where epsilon is the plate velocity divided by instantaneous height. So v divided by h. So instantaneous height is the, in this case I can like explain you. Suppose this is our workpiece, and this is one plate, and this is another plate, and in this case here uh, height is h, and this plate and these plates, this plate is coming down with velocity v. Now this v by h is known as strain of heat. So let's come to the next property. Just introduction I have given you about strain hardening. You must remember these formulas. In malleability is the property of a material by which we can cold work it. यानी हमको जितना कोल्ड वर्किंग जो है वो अलाउ करता है पर्टिकुलर मटेरियल, वो उसका मेलेबिलिटी प्रॉपर्टी कहलाता है. जितना ज़्यादा मेलेबिलिटी होगा किसी मटेरियल का, उसको आप ज़्यादा कोल्ड वर्क कर सकते हो. So a malleable material is capable of undergoing plastic deformation without fracture for more time, we can say, or a malleable material is capable of undergoing more plastic deformation without fracture. So a malleable material should be plastic, but it is not necessarily to be strong, because Generally, strong materials, will not go more deformation. Lead, soft steel, wrought iron, copper, and aluminum are some of the materials in order of dimensioning malleability. So let's now come to our point of this lecture, like what is the difference between cold working and hot working. So now we will see the conclusion here. So what is cold working? Now you can say cold working is the working below recrystallization temperature. That's what I have mentioned here. Working below recrystallization temperature, that's the definition of cold working. Now what are the advantages of cold working? So first advantage, now again I would like to request you that these all points are uh, questions those asked in different exams, so you must remember. So in cold working we will get better accuracy and closer tolerance, both are same point only, and better surface finish, because in hot rolling impurities will come over the surface, so surface finish will not be good. But in cold rolling surface finish will be good, प्रोवाइडेड शर्त क्या है कि जो मटेरियल आपने लिया है पहले उसमें कुछ इम्प्योरिटीज सरफेस पर नहीं होनी चाहिए। उसकी अच्छी सरफेस है तो कोल्ड वर्किंग से उसका सरफेस डैमेज नहीं होगा। दैट्स द पॉइंट आई वुड लाइक टू मेक हियर। मीन्स कोल्ड वर्किंग डज नॉट अफेक्ट द सरफेस फिनिश, but hot working affects, it reduce the surface finish. So in case of cold working surface finish will be retained. You can remember this point like this. Now strain hardening increases strength and hardness. So in cold working strength and hardness both will increase, whereas ductility will decrease. Remember, in strain hardening, in cold working, strength and hardness will increase, whereas ductility will decrease. Grain flow during deformation can cause desirable directional properties. That's again a very important point, because as I have mentioned, after cold working grains will be like this. So you can get the directional properties, like such kind of material will have very good tensile strength. So directional properties can be achieved. No heating of the work is required, so less total energy. Now if you see the disadvantages in case of cold working, then as the force required is high, so equipments of higher forces and power is required. So you can conclude this one like more power requirement in cold working. Surface, yeah, that's the point that I make. Surface that you have taken initially, that must be free from scale and dirt. Now ductility and strain hardening limit the amount of forming that we can do. Here is the problem. If you continue cold working, fracture may take place, or it will not permit more deformation. So what we can do for more deformation, we can do the heating. That's here it is mentioned, annealing we can do. So remember, in cold working, if you're going for lower deformation, that's allowed, but if you want to go for more deformation, that's not permittable, as fracture may take place, because in increase in the strength and hardness. So what we will do, we will do the annealing. Now here comes the important point, that what affects what annealing does in terms of mechanical properties on the material. So in case of cold working, as I mentioned, ductility will decrease and hardness will increase. So annealing will do just opposite of that. Annealing will increase the ductility, whereas hardness will decrease. So it will allow somewhat more cold work. Now some metals are simply not ductile enough to be cold work. Yeah, that's true, because some materials, those are brittle in nature, you cannot go for the cold working for those materials. Now here is a graph that shows amount of cold work. So if you go for cold work, strength and hardness will decrease, whereas ductility will strength and hardness will increase, whereas ductility will decrease. And this is how the grain size will change. Now coming to hot working, it is working above recrystallization temperature. And now what are the advantages? As in cold working, more power was requirement, so here less power is required. Or properties of the metal is largely eliminated. Sorry, porosity. So in case of hot working, porosity of the metal will be removed. So porosity in the sense, uh, let me explain you this. Suppose your grains are like this. So this space, I am talking about this space. This space can be removed due to hot working. So this is the advantage that we have got here. Now again, next advantage is like the grain structure of the metal is refined. The impurities like slag are squeezed into fibers and distributed throughout the metal. It will get distributed, or surface area will increase. The mechanical properties such as toughness, elongation percentage, or reduction in the area percentage, the reduction in the area that we can get, that is more or improved. Now if we come to the disadvantages part, first disadvantage is it requires expensive tools that can bear high temperature. It produces poor surface finish. So it produces poor surface finish. Remember this point, this is very important. Surface finish is poor due to the rapid oxidation and scale formation. Now due to the poor surface finish, close tolerance cannot be maintained. So what was the advantage we were having in cold working, like good tolerance? So here tolerance is not good. And there we were having good surface finish, here surface finish is not good. So you must remember these 2 points. Now if you see the microstructure, so this diagram particularly is shown of the rolling process out of the 4 process that we have seen. So this diagram is of rolling process. So from this side material is coming this side, and after reducing the diameter it is coming out on this side. So you can see the grain structure here deformed grain structures are there, this one, and after some time recrystallization is taking place over here because it is going through the change in the microstructure. So recrystallization starts here at this point. Now can we take this in next lecture, as already about 13-14 minutes are there. So we will take annealing in next lecture, and we will see the previous year ES and GATE questions. So see you in the next lecture. Thank you.